The biggest mystery is just how come we don't see anything? But they were thinking about self-replicating machines that would spread across the galaxy and slowly, essentially convert normal matter into more probes. And the terrifying thing about what they wrote was how easy it is. Well, maybe we're the first. It never happened before. We are the first example of someone to build in these types of machines. Why don't we see these probes? Why don't we see AI everywhere? Maybe it's just so slow that they can't reach us. As they showed in these early papers, that doesn't make sense. We may be living in the oasis, the backwater of the universe, where for whatever reason, we are a weird fluke of a galaxy where that just hasn't happened. If an alien species was looking out at the cosmos, so they'd probably notice that Earth is unusual, they'd probably notice that life on planet is maybe unusual.
The This Is World channel is partnered with IQM, one of the world's largest quantum computing companies.
It's a great pleasure having you here.
Yeah, thank you so much.
Don't you think, because very often we use term alien civilizations, don't you think that we should maybe call them machine civilizations? Because, maybe somewhere there, deep inside the universe, there is superpower AI or something like that that can colonize another planets. Maybe this is, the global misunderstanding, calling them alien civilizations.
Yeah, this kind of comes back to some early ideas that sort of von Neumann had, actually. So there's this idea called the von Neumann probe in the 1960s, and the Bracewell probe and around the same sort of time. And these were two physicists who suggested, along these kind of lines, not necessarily they were thinking about AI. I don't think the term AI was really in popular lexicon at that time, but they were thinking about self-replicating machines that would spread across the galaxy and slowly, essentially convert normal matter into more probes, or what I guess in modern parlance we might say computer substrate. It would go around just converting dumb matter into smart matter, essentially like a 3D printer. And the terrifying thing about what they wrote was how easy it is. So, Voyager 2 is one of the fastest spacecrafts we've ever made. It's leaving the solar system, but it's still pitifully slow. It takes tens of thousands of years to reach the nearest stars. And so people normally might use that as a solution to the so-called Fermi Paradox. Why don't we see these probes? Why don't we see AI everywhere? Maybe it's just so slow that they can't reach us. But as they showed in these early papers, that doesn't make sense. Even traveling at Voyager 2 speeds, you can actually circumnavigate the entire galaxy a few times over, given its current age. So the galaxy is about 100,000 light years across. So even if you traveled, say, 1% the speed of light, you could go across the entire galaxy over 10 million years, from one end to the other in 10 million years, and you would be able to do that journey over the lifetime of the galaxy, which is about 10 billion years, 1,000 times over. So there is plenty of time for even slow spacecraft, AI, 3D printed probes, to have spread across the galaxy and converted everything by now. And that is known as Hart's Fact A, because that clearly hasn't happened. Otherwise, we wouldn't be here to talk about it. The Earth has not been turned into a computer. We do not see obvious evidence of manufacturing in the solar system or something like this. So that is a puzzle. There's two resolutions to that. One is to say, well, maybe we're the first. It never happened before. We are the first example of someone to build in these types of machines. We haven't obviously built a 3D Bracewell probe that could 3D print itself across the universe yet, but it's conceivable we could get there in our lifetime, I would say, that we could probably build something like that. So one solution is we are the first. Another solution I like to point out, which I don't hear spoken about as often, is that maybe actually that is typically what happens. Maybe most of the galaxies around us, that has already happened, in fact. We would necessarily, as organic beings who naturally evolved on a planet, we could not develop in those galaxies. It would be impossible, because those galaxies are already essentially sterile, because they all have been turned into computer substrate, if you like.
You mean early galaxies?
Maybe a few billion years ago, these nearby galaxies around us and beyond, maybe 99% of the galaxies in the universe have been converted into computers at this point, essentially. There's no reason why that couldn't have happened. And that would naturally fit in with our expectations of life should be common, intelligence should be common, AI should be common. It would naturally fit in with that sort of mediocrity principle type view. And it would also explain why we live where we live. We could not live in one of those galaxies. We may be living in the oasis, the backwater of the universe, where for whatever reason, we are a weird fluke of a galaxy where that just hasn't happened. In most galaxies, that happens pretty quickly, but in our galaxy, for whatever reason, just by pure luck probably, no other civilization previously developed. So I think us being the first in our own galaxy can also be comported with the idea of life being common elsewhere.
What revelations, is the Webb telescope bringing about early galaxies?
A lot. It is helping us to understand those galaxies, and it's providing some surprises. I would say, to lead off from our previous conversation, it's not really helping with alien searches too much. The galaxies that James Webb is looking at are so distant. They are, literally on the other side of the universe. When the universe was first forming, essentially, they're 13 billion light years away in some cases. So vast, vast distances. And so these galaxies are surprisingly well formed, given the age that they appear at. So based off the redshift of these galaxies, we can date them, and we can tell that there are some galaxies which are formed within the first couple of 100 million years of the universe existing after the Big Bang. And that's very fast. Especially, we expected there to be sort of proto, very small galaxies, but these are very large, well-sized galaxies, too large for us to be able to really expect them before James Webb launched. And so that caused a lot of controversy. People, there were headlines out saying Big Bang Theory is wrong and things like this. But there's another explanation. Either the Big Bang Theory is wrong or our understanding of how
Maybe it is.
It could be wrong, or it could be that the formation, our understanding of how galaxies form could be wrong, right? There's two possibilities. Now, if you're going to throw away Big Bang, which is really to say lambda CDM, which is a cosmological model which explains the cosmic microwave background, it explains large-scale structure, it explains the cosmic infrared background, it explains a huge number of observations at this point, polarization of the sky, B modes, all this kind of stuff. So if you throw that away, you have to sacrifice a lot of scientific predictability. Some of the predictions of the lambda CDM are within 0.01% of these multipole moments that you measure on the sky. So just really beautiful level of precision in terms of the predictions. Or it could be that the physics of gas coming together, that's plasma astrophysics, right? That's how gas combines, how it gets funneled into black holes, how those early structures form. That's very difficult to simulate. That's a much harder problem, physically speaking, to work through than cosmology. Cosmology is actually kind of a simpler problem.
That's my next question, David. Is it not undermining actual cosmological model?
Undermining it?
Yeah.
No, I think I would say it either undermines the cosmological model or it undermines the galaxy formation model. One of those is undermined by those observations. And because
that undermining everything, right?
I don't think you have to you don't think you have to throw away both. You have to throw away one of them to make sense of this puzzle. One of them has to be wrong. It'd be surprising if both were completely wrong, because that would seem a little bit excessive to throw both out. And as I said, the cosmological model explains so much data. It's a hard sell to get rid of it. Whereas when we look at, I'll give you an example for the star formation. So when we're forming galaxies, you have to predict the number of stars that are formed as a function of time, and how gas combines together to form giant molecular clouds that then collapses to form stars. That's the process of building these proto-galaxies. Now, a lot of the rates at which gas collapses down and forms those stars is very difficult in a computer to simulate. You have to simulate, think about it, every gas particle, trillions and trillions and trillions and trillions of particles. You have to simulate in a computer to come together, and we don't have the resolution, even with modern computers, to do that. So we have to use these very blocky, it's kind of like playing Donkey Kong or something, like these kind of very blocky approximations of how these gas clouds actually form stars and galaxies. So we don't completely trust those models, because we know we're limited by our computers. We know what we put into those simulations, and we know it's not right, but it's an approximation, because what else can we do? And yet it seems to more or less explain the star formation that we see in our galaxy. So that's why we feel fairly good about it. But then when we take those same models and we apply it to the early universe, it doesn't seem to work. or Big Bang Theory is wrong, but that's one possibility, right? It doesn't seem to work. And it's probably because, I mean, in fact, there's a kind of growing consensus this is the case, that those simulations that we used and seemed effective for the Milky Way were largely calibrated to be so. When you do these simulations, there's a huge number of tuning parameters, we call them. And that's because of these approximations. So you have to say, what is the efficiency at which gas collapses per unit time? And you just have to basically choose a number for that in the simulation. We don't know what to choose. So what the simulators normally do is they choose that number so that it matches the stars in the galaxy. So they tune a lot of these numbers so everything looks good. Now, if those numbers are different in the early universe to how they are in the modern universe, then the simulations won't work. And there's good reasons to think they would be different because the environment of the early universe is completely different. It's a much warmer, hotter, denser universe than it is today. So why should the efficiencies and these other tuning parameters all be the same? So I think that's a much more likely answer.
But talking about the universe all the time, we use the term, billions of billions years, 30 billion years in the universe, trillions of trillions of something. These numbers are real for human mind?
No, it's hard. I mean, when you hear like the national debt is trillions of dollars, who can really get their mind around that compared to our typical amount of, dollar bills that we play around with in our hands? So yeah, I think the human mind really struggles, but I certainly feel comfortable with it as a mathematical construct. If you write down 10 to the 12, a trillion.
Maybe we are not capable of understanding that numbers.
I think we can, it depends what you mean by understand it. Can we visualize 10 to the 12 objects in our mind? No. We cannot visualize that many objects, but do we need to visualize that many objects to make progress with our mathematical models? I think that's clear that we can. We don't need to necessarily be able to visualize what a billion objects looks like to be able to multiply 1 billion by another number or something. Like we can make progress with that in our models. So it is I certainly feel when I look up at the sky and you look up at all the stars, and you're only seeing a fraction, of course, of the stars in a local universe, let alone that's truly out there. The mind cannot truly fathom the vastness of even the local universe, let alone the entire cosmos beyond. But I don't lose sleep about that aspect. I mean, that's just why should we expect that a primate, which is what we are, has the ability to visualize astronomical scales in our minds? There's no reason why it should be. I mean, there's no reason why the universe should be comprehensible to us. It is a miracle that it is as comprehensible to us as it is. Why is it that there's no evolutionary benefit to us being able to understand cosmology? Right? There's absolutely no benefit to that, but apparently we can to some degree. We have pretty good models. Why can we understand quantum physics to remarkable levels of precision that we can make these experiments and build semiconductors and do quantum teleportation and quantum computation? I mean, there's no evolutionary reason why we should be able to do those things. So I think it's a miracle that the universe is as comprehensible as it is, but I'm very comfortable with the idea that there could be stuff that we will never truly be able to wrap our heads around.
Hello, quantum enthusiasts. Our partner, IQM, has created a free resource for you to learn and access real quantum computers. Create an account on IQM Resonance and start learning. Find the link in the description.
Under your research, which informations ever shocked you the most about aliens, civilizations, about, that scope of your research?
Yeah, there's many mysteries. I think the biggest mystery is just how come we don't see anything? I mean, it sounds a little bit terse to put it like that, but there is and a lot of people would push back and say, we've barely scratched the surface, maybe they're communicating ways that we can't see or doing things we don't detect. But the shocking thing is the universe, as far as we can tell, from everywhere from the edge of the universe that James Webb can see, all the way up to the local galaxy, everything is apparently consistent with natural. Every star we've looked at, every galaxy, it all is consistent with a natural explanation. And that's kind of shocking that a natural explanation explains so much. And so that, I mean, why don't we see the occasional star that's been engineered in some obvious way? Why don't we see relics in the solar system, like spacecraft just floating around? Or why don't we see warp drive trails through the sky? Why don't we see laser beams shining at us? Why don't we see galaxies that have been converted into just computer substrate or something? You know, these things, we can think of experiments to do it. We've surveyed 100,000 nearby galaxies looking for what we call a Kardashev type 3 civilization, these kind of these greedy, energy-hungry civilizations. And of 100,000 galaxies, we don't see anything. And that's just very lonely. You know, it's very odd that we appear.
Sad.
It's maybe sad, or maybe it's like playing the universe in sandbox mode. You know, if you play a computer game and there's no opponent, you just get to play and do whatever you want in the game. And maybe that's the way it is for us. Maybe there's no agent to stop us from doing whatever we want. We could expand through the galaxy and no one's ever going to prevent us. There's no barriers. We could essentially do whatever we want. And that's quite exhilarating.
So we have two options. We are either totally alone or surrounded by hidden aliens. Don't you think that is basically, you know, Pascal wager?
Yeah. So maybe, I mean, there's no obvious...
That's like, you know, Pascal's wager.
Yeah, so Pascal's wager is about a benefit to you, though. So what would be the benefit to us in believing one or the other in this case? There's no obvious benefit for you to believe in aliens or not to believe in aliens in this case. Believing in God, in Pascal's wager, has a potential benefit because when you die, you go to heaven. But it doesn't really matter if you believe in it unless they have some way of sucking up your spirit or something that, you know, you have some idea of that. But I think if you're going to go to that far, you may as well just invoke fairies or Santa Claus or Easter Bunny, Pascal's wager, everything. I should just Pascal's wager in the most insane thing because that would maximize my benefit. So, I mean, personally, I like truth. I try to seek, you know, it's not always going to be something I like. And usually as a truth seeker, it's probably the opposite of what I want. And so I really challenge people to ask themselves this question: what do you love more? What you want to be true, or what is true? And that's a really difficult question to like look in the mirror, stare hard at it, and ask yourself, what do I want more? And so often, even in politics and modern society and social media, you'll see a story pop up that maybe agrees with your worldview. Maybe a political figure you don't like has been accused of doing something bad. And you will just, you know, be rubbing your hands together, so happy that this politician's been caught out for doing something bad. But that's because you want that to be true. So maybe that might be a pause for concern. You know, I actually really would like it if this politician was caught doing something dirty. So maybe I should be more skeptical about that idea, and vice versa when it's a good for one of your friends. And I think this is one of the things we really struggle with. Is science is all about, you know, just what is really true. And our emotions, we are human beings doing science, will cloud that process. And we have to guard against it really consciously and forcefully when we do that. And I think aliens is a great example of this. But I think it's a lesson for life. It's a lesson which translates to every aspect of society. Really ask yourself, what do you want more? And often a lot of people, if they're being honest with themselves, will probably prefer, you know, their favorite ideology to win out rather than necessarily the truth to bear out.
What is the mechanism of the halo drive that you propose?
The halo drive, yeah, this was a fun little project I worked on about black holes and really asking what are the limits of transportation in the galaxy. So Freeman Dyson, to give the little backstory behind this, had this idea of using two neutron stars that were in a very compact orbit, circling around one another. And they get so close that they move close to the speed of light in their in-spiral phase. And so he suggested you could do a gravitational slingshot around one of those stars. And because they're moving so quickly, you could steal velocity essentially close to the speed of light and then travel between the stars. And the beauty of this is that you're stealing energy. So your spaceship doesn't really require a propulsion system. It just drifts in at the right time and comes out. The problem with this is that that's like a blender, right? So these stars are moving so fast in those final moments. It's like trying to throw a stone into a blender and hope that it bounces off the propeller at the right moment. And it's a very hazardous environment to fly into, a high radiation environment. So maybe not a healthy thing to do. So I suggested, hey, why not replace those those neutron stars with black holes? And a black hole has the advantage that you don't need to get so close to it because we could use light. So we shine a light beam and we just miss the black hole just to the side.
Black hole as a cosmic engine?
Yes, we're using it as an engine to power our spaceship. So there's two black holes, or maybe even just one that's moving very quickly, and we fire a light beam, a laser beam, and it skirts around the edge, around the event horizon. It doesn't quite go into the event horizon, just off the event horizon. And so it will orbit around and complete one, it's called a boomerang geodesic. It kind of looks like a mirror. So you can actually see your reflection. If you looked at just the right angle around a black hole, you could see yourself. Yep. So this light beam skirts right around and comes back to your spaceship. And when it does, it will, like throwing a ping pong ball off a moving wall, it will pick up energy. Imagine like a tennis racket that's moving through space and a ball hits it, it comes off with more energy than it initially hit. And so this black hole that's moving towards you will force the light beam to pick up more energy. So it will get blue shifted, and then that will hit your spaceship and propel you forward. So the beauty of this system is that you could propel very, very large vehicles through space very, very fast. So you could literally take Jupiter, the planet Jupiter, and propel it at relativistic speeds through the galaxy with this thing, and the black hole wouldn't even notice because it's so massive. So if you wanted to move an entire civilization or a huge amount of mass, this would be the great way to do it. And there's about 1 million black holes in the galaxy altogether. We don't know where they all are, but we expect there are about 1 million from stellar formation history. And so there's a network essentially out there waiting for us to tap into. And I like to think of it a bit of like a highway system, right? So these are the highway points between each black hole, and you can accelerate and decelerate between these points. And then you get off the off ramp at each one and then you go to your local star system.
So could the halo drive mechanism push a ship to the speed of light?
Not to the speed of light. It would be limited by the speed of the black hole itself. So these these black holes have varying speeds, but some of them
close to speed of light, right?
Yeah, I would say maybe like 30-40% speed of light, something like this. Yeah.
Is it technically possible to create a prototype of the halo drive?
Possibly. We don't obviously have a black hole. That's the big problem. So you need a black hole to test this. There are some analogies to black holes we've been able to make in the laboratory setting called acoustic black holes, where instead of light being trapped in an event horizon, you can get sound waves to be trapped in an event horizon. And so you might be able to do a kind of sonic version of it, more or less just to demonstrate the idea. But really, if you wanted to truly utilize this thing, you need something which can do this light reflection technique, which is what the black hole serves. So you need something that's moving fast and can bend light around it. So for that, you really do need a black hole. Yeah, I mean, when I approach problems like this, I think of stories as science as a conversation. So you have to listen to what's been said before. And so imagine you're at a cocktail party and there's a group of people talking. So I walk into the room and I hear Freeman Dyson talking, and he's talking about these neutron stars and how they merge together. And in my mind, I'm realizing there's a problem with that suggestion. And so I hear what he's added to the conversation. And I think we can all do this as scientists. We can all think, is there anything about that which could be improved? Is there anything about that which may be an assumption there that I don't like, that maybe I might challenge? And so our job as scientists is not to necessarily reinvent the wheel, but to take ideas that have come before, we stand on the shoulders of giants, and to tweak it and to say, is there a better way of doing that? So this is a tweak. And I hope other people will tweak it in the future. I hope someone else will come along and find an even better way of doing it.
So one futuristic question, if you had a halo drive, how would you use it?
You could use it to move civilizations across the galaxy. How would I use it? I guess I would love to travel and see another Earth-like system and just see what is it like? Yeah, are there other creatures on there? So for me, I mean, some astronomers are drawn by the question of how the universe works. So maybe some people would travel to the center of Sagittarius A star or something. Maybe they'd fly themselves into a black hole to see like what happens. Well, how does the physics work? But other scientists and other astronomers like myself, I think we're more drawn to the question of life, and that has always been the ultimate question for me. So I would want to travel and understand how special are we?
What are Dyson's theories?
So this is again one of Freeman Dyson's brilliant ideas, and he was thinking about the ultimate limits of energy harvesting. So we know we're going through a period on the Earth of building more and more solar panels on this planet, of harvesting solar energy. And of course, we're kind of limited by the surface area of the Earth eventually. I mean, we're nowhere near that limit right now, but in principle, you could tile one hemisphere of the Earth completely in solar panels, and you wouldn't be able to do any better than that. So the next step might be to go to space. And in fact, some companies are trying to do this as well right now. They're trying to build space stations, space satellites that will have solar panels and then maybe beam the energy back to the Earth. And so you might grow more and more and more of these things. And eventually you would have so many of them in orbit of the sun, which of course is your energy source, that the sun is basically enshrouded in satellites to such a degree it almost becomes invisible from another star system. So when Dyson described it, he did use the term sphere, I believe, in that original paper, but most of the time we think of it today, we think of it not as a monolithic structure, but more of a swarm of material of some kind. It could be, I mean, a solid structure just isn't stable. So that's why we tend not to focus on that. It would have enormous tensile strength, it would break itself apart, and even the strongest materials we know of, no way could sustain this kind of force. It'd also be unstable to gravity. If you just prodded it on one side, the sphere would fall into the star. So there's lots and lots of problems with a solid sphere. But a swarm material is quite reasonable, and it would be the ultimate way for a civilization to harvest vast amounts of energy from their star.
Could a Dyson sphere obvious in our data?
Yeah, people have looked. So I mean, likely yes, but not with 100% certainty it would be visible. So what's happening is on the inside of that sphere, or the inside of that swarm, they are collecting energy from the star. Now that energy can't be destroyed, and by conservation of energy, energy has to be conserved. So the energy has to come out somehow. Otherwise the thing would just get hotter and hotter and hotter and it'll all bore to death on the inside. So the energy has to come back out. So the question is, how does it come back out? If they think about your laptop or a piece of like a camera that's working, it will get warm. So it's turning the chemical energy in the battery into thermal energy, is essentially what it's doing. And so the amount of thermal energy that comes off your laptop will be the same as the chemical energy that went into it, plus the light, plus the sound. That's the other two sources of light, of energy which come off it. But all of those energy sources have to add up. Everything that comes out have to equals everything that goes in. So these Dyson spheres have to be emitting energy, a lot of energy, a sun amount of energy, a star amount of energy in some way. And if they're doing calculations, if they're doing computation, it would come out as thermal waste heat in the infrared. But it doesn't necessarily, it could come out in neutrinos, it could come out in gravitational waves, but it has to come out somehow.
I have some questions to you from our viewers. We asked them before our interview. Do advanced worlds go radio silent on purpose, you know, the dark forest idea?
Yeah, dark forest is growing in popularity because of obviously the trilogy of books and the Netflix series which have popularized this idea. I'm a little bit skeptical about dark forest, mostly for two reasons.
What is dark forest idea?
The dark forest idea proposes that civilizations do not produce radio waves, do not communicate with us and make their presence known because they're essentially fearful of some kind of retaliation, of some kind of malevolent species attacking them in the future. So therefore the wise thing for us to do would be to stay quiet. We shouldn't be doing any sending out laser beams or radio waves because we might get detected and then someone might come along and destroy us. So it's motivated by fear. Is what it really is. It's a theory of fear. And it's not unreasonable to be fearful, because certainly past interactions on the Earth have been destructive.
So this idea, I mean, that we are silent because we are protecting ourselves.
Yes,
right?
and that all species would eventually come to the same conclusion, and those that don't would be destroyed so swiftly that they don't matter. I would say the reason why this doesn't make sense is if you really want to scrub competitors from the galaxy, right? Because why would you destroy another civilization? What's the motivation? Presumably it's for protection against yourself, that they might one day overtake you in technology and become a threat to you. So if you really want to scrub out threats, you would do it preemptively. There's no reason to wait until they develop technology, right? So as we talked about earlier with these Bracewell probes and von Neumann probes, you could colonize the entire galaxy by now thousands of times over, given the age of the galaxy. So this is called the berserker hypothesis. So the berserker hypothesis is that you'd preemptively go around sterilizing planets. So you don't wait for them to emerge and then do it, you just clear the table to begin with. That's a much safer strategy in game theory than waiting for them to come around, because then when they've come around, they might surprise you. They might have a nuke that they can sneak off and hit you with, right? So why would you wait to that last ditch moment to play this dangerous game? The second reason why I don't like it is because of the existence of telescopes. Yes, sending out a radio wave will broadcast your presence, but another advanced civilization will surely have telescope technology, and so they will know that we're here whether we send that signal out or not. They're smarter than we give them credit for. We are already imagining telescopes that will be able to image cities on nearby exoplanets, be able to image the thermal heat island effect, be able to image their rivers and mountains and landscapes on other planets. So if there was another civilization that could potentially threaten us, they already know about us, and there's no reason panicking in my book about sending out a radio signal. That's not going to change their knowledge of us. They already know we're here.
Do you know what a Zoe hypothesis is?
Yeah, I guess it's kind of inspired from Star Trek. The Prime Directive in Star Trek has this idea that you don't interfere with the species until they reach a certain level of development. Yeah, that one is intriguing. I do quite like the zoo hypothesis. It does have some problems on coordination. So because of the finite travel speed of light, imagine you are born in a certain random location in the galaxy, and there's civilizations all around you in different directions. Now, they all have to know not to mess with you, right? So let's say you just appear, boop, you just appear on August 1st or something. Okay. All these civilizations now around you have to know not to interfere with you. Yeah. So somehow, let's say civilization over here has to communicate and send all the way around this circle of this sphere really around us to tell all of these civilizations, don't mess with this guy. We just saw them popped up, let's let them develop first. And so one of the challenges is because of the spontaneity of people keep popping up, there might be a new civilization emerge right next to us that doesn't know about this rule and will just communicate with us just randomly because they don't know about this prime directive. So the problem is coordination. The galaxy is so big and the speed of light is so slow that it's almost impossible to coordinate all these civilizations. So there's actually some great work by a colleague of mine, Duncan Forgan, and he created a galaxy simulation with finite light speed travel and showed this is a real problem. Like, it's very hard to maintain zoo hypothesis because people just break it because they don't know about the rule, and the speed of light's too slow for you to tell them in time to not do it. So I do like it, but it only works in some very narrow sets of assumptions.
Is our solar system ordinary or extraordinary compared to the others?
Yeah, people argue about that. And I think it depends on what qualities you look at. There are some aspects of our solar system which are clearly odd. I mean, we mentioned the sun. earlier. So the sun is a yellow G-dwarf star, and only about 2.5% of all stars in the universe are G-dwarfs. Over 80% of stars in the universe are red dwarf stars. We call them M-dwarfs. So to me, I've always been bothered by this, actually. It's unusual that we do not live around a red dwarf star, because all things being equal, there's about a 40 times higher probability that you would be born around a red dwarf than a G-dwarf, just by the sheer numbers of stars being manufactured in the universe. The universe likes to make small things more than big things. Big things are harder for it to make than small things. So it tends to make a lot more small things. And then the solar system itself also has unusual structure. Has a Jupiter-like planet in it. In fact, it has two, Jupiter and Saturn. And only about 10% of Sun-like stars have Jupiters. We can tell that from exoplanet surveys. It, of course, has a very ordered multi-planet system. It has 8, maybe 9 planets if you include Pluto. And that's also kind of unusual. Most planetary systems we look at aren't quite as packed and dense as our solar system. We do see some cases where it looks a little bit like the solar system, but that's somewhat unusual. And then in terms of the Earth, that's a big unknown. We still don't really know how common Earth-like planets are around Sun-like stars. We do see evidence that about 1 in 6 red dwarfs have them. So that we can tell. The red dwarfs are easier for us to do in astronomy because they're smaller. So when a planet passes in front of those stars, it's easier for us to detect the presence of those planets. A Sun-like star is just still a little bit beyond our capabilities to detect those Earth-like planets. So estimates still range anywhere from 1% of Sun-like stars have Earths all the way up to 100%. There's a huge range depending on who you ask. I think the best answer is we just don't know. We need a better telescope to figure that out. And so it is quite, and then, there's other aspects of the Earth like the moon. We have a large moon. That's one of my passion projects, is trying to figure out if there are other moons out there around these planets, which there surely are, but the question is, what do they look like? How typical is our own moon? And for a long time, people have been suggesting our own moon might be part of might be the key as to why the Earth has life on it, in fact. So this is called the rare...
Do you still believe?
Do I believe that?
Yeah.
I try not to stake a claim of belief until I have evidence either way, because I'm trying to be a good scientist, right? So I don't want to say, oh yeah, that's definitely true before I have any other evidence besides from the Earth to look at. So I think we need more examples to be able to build that up, and that's what I'm trying to do by looking for exomoons. But I think you can make a good case that that is so, and the argument kind of runs that the moon stabilizes the obliquity of the Earth, so our tilt is stabilized by the moon, and it also may be helped with oceans and stripping off some lithosphere during the giant impact that happened when the Earth first formed. So those features may have been beneficial to the emergence of life on our planet.
NASA informed 2 weeks ago they found that, biosignatures probably on Mars, but still in that statement there is so many terms like probably, not 100%, maybe. What do you think about that?
Well, it's just another round of the rodeo, really. I mean, we've done this thing so many times now. There've been probably a dozen claims of life. Even in my lifetime, I think there's probably been a dozen claims of life, but even before that. So Mars in particular has been subject to numerous. I mean, I remember as a child, Bill Clinton stood on the White House lawn and talking about the Allen Hills meteor, which was at the time considered very strong evidence for life. On this meteor, if you zoom in with a microscope, you can see these worm-like fossils on the surface of the meteor. And that sparked huge interest that this was the first clear evidence for life. And then subsequently that evidence dissolved a little bit. And really the reason was because experimenters were able to show that under typical Martian-like conditions, especially with running water involved, you can actually make stuff which looks similar to this. Not exactly the same, but you can get some morphological features which look kind of the same as those fossils without any life involved, just by the way that water interacts with mineralogy on the surface of Mars. So when that happened, people started to maybe question those fossils a little bit. And also the fossils were tiny. They were so small. I think they were smaller than even the smallest bacteria on the Earth by quite a long way. So people were kind of skeptical how it could even be a fossil to begin with. So there was a few reasons why people doubted it. And we've had that, with phosphine on Venus. A few years ago, there was...
I remember on MIT, right?
Yeah. There was a...
In the cloud.
Yes, yeah. There was a team led by Jane Greaves, Sarah Seeger, who suggested in the upper atmosphere of Venus there was phosphine, which was a product of life, because it was very difficult to understand how in Venusian chemistry that could be produced abiotically at the time.
And the temperature is much lower.
Yeah, it's actually close to the Earth's surface as you go high up, and the pressure is similar as well. So that seemed compelling. But then you would require some kind of bacteria that can stay aloft, I suppose, which is maybe difficult exactly to understand how that would work. But again, that evidence has been challenged in the subsequent months and years since. So this has happened so many times now. We could keep going, listing all these different examples of life claims. But the continuous lesson is that always other scientists will give it a breather, give it a couple of years, and see what the skeptics are able to pull out. And that's how science works. Science works by someone making a provocative claim, and I like provocative claims. I encourage scientists to make them because that moves science forward by these provocative claims. I don't want to say everybody should just be conservative and never put their neck out there. No, we need people to make a leap and challenge science, so I think that's great. But the other half of science is the community is going to come and try and poke holes in that argument. And really, science is like a crucible where people, you burn away all the irrelevances until you're just left with whatever the residue of truth. That's all that's left over. And that's what this process is. Skeptics have to come and they have to attack it. And the things which survive are the true things. And so we'll see in the next couple of years what they have to say about this.
So where scientists should stay silent?
Stay silent about this?
Yeah.
What do you mean? Tell me more.
About the barrier, about the difference between, science and pseudoscience. Where or when scientists should stay silent? Should they know it is not science?
I think, it's difficult, and there's been arguments about that.
Where is the barrier?
The dividing line, yeah, I understand your question. Popper used to give us a clear dividing line, right? This falsifiability criteria was sort of seen as a clear dividing line for a long time. But in cosmology and string theory, there are ideas there like the multiverse in cosmology, which are not testable, not falsifiable. There's no way we can, by definition of being in the universe, we can possibly leave our universe to test the presence of other universes.
Maybe the black hole in that vision, also the black hole is the cosmic tunnel to another universe. You mean that vision, right?
Well, perhaps there are connections, but most models don't even involve connections. In eternal inflation, for instance, there are universes which are moving away from each other faster than the speed of light. So there's no way they could ever possibly interact with one another. These are like bubble universes. And in fact, there's an infinite number of these bubble universes that form in eternal inflation. So these are disconnected multiverses from us. And so it's difficult to know whether you would call that science, but there's some benefits here. Inflation can explain the early universe very well.
One thing, I think that is a huge misunderstanding because all world think that speed faster than light, it's in opposition to the Einstein theory, but it isn't.
No, space can expand faster than speed.
Einstein just only said that a speed of light a constant.
It's locally.
It's locally, right. But not the fastest. So maybe the speed of something is faster than light.
Yeah, I mean, certainly there are hypothetical particles like a tachyon which travel faster than the speed of light. We have no evidence for such a thing, but mathematically you can construct such a particle.
But I'm sorry, I'm interrupted.
Yeah, I think the idea of universes being fastened away from each other is just one flavor of multiverse. There's many different types of multiverse, in fact, that people have proposed. But I think a general theme of them is that they are completely disconnected and unobservable to us, even in principle. And so that would fail Popper's criteria of being falsifiable. But on the other hand, they have explanatory capability. And so maybe what makes a credible scientific hypothesis is not so much we should be concerned about this Popperism definition, but really ask about the explanatory focus. And the multiverse can explain lots of stuff. It can explain the early universe, the inflation period, but it can also possibly explain the fine-tuning problem, which is why is it that the constants of nature seem to be so well tuned that it makes it suitable for life. Because if you adjust any of these numbers significantly, even atoms don't form, stars don't form, we would not be here. So there may be a huge number of sterile, barren universes where life cannot emerge, and we would necessarily emerge in the isolated cases where everything is just right to allow for life. And so again, it can explain why those constants are the way they are, but it's almost an explanation of last resort to some degree. I think we would much prefer it if we had an explanation that was more fundamental than that, and it said, there's this simple, elegant equation, and it can predict all of these constants, and they have to be the way they are because there's no other option for them to be but these numbers. That would be the most satisfying solution. But if we can never find that, and we may never find that, we might have to accept that. Maybe humanity will never figure out an answer to that question. The backstop solution is essentially, well, it has to be that way, otherwise we wouldn't be here to talk about it.
What's the probability that our generation will find life somewhere there in the universe?
I wouldn't want to hazard a guess. Yeah, I'm optimistic. I'm hopeful. I really do hope that we can detect life. I try to remain very agnostic about it, though. I think it can be, one of the things that really concerns me as a scientist is when scientists prejudge what the answer is. And so with the question of life, I actually got upset with the SETI Institute recently, and I love the work that the SETI Institute does. The SETI is the Search for Extraterrestrial Intelligence. It's in the US. But they posted a tweet, and it just kind of bothered me because they said the question is no longer if, but when for detecting life. And that sort of rhetoric bothers me. It's a bit of a nitpick, but you are essentially deciding what the answer is as a scientist. A scientific institution is saying life is definitely there. Even though we don't have the evidence for it yet, we've already decided the evidence is there for it. And that's a dangerous position to hold. It's unscientific. Science is supposed to follow evidence, not decide what the answer is before we have the evidence. So that's just an initial problem. And second, it can lead to something called experimenter's bias. So there was a bunch of experiments done by, I think it was Rosenthal in the 1960s in psychology that showed how dangerous experimenter's bias can be. So they did this experiment where they got these rats and they labeled them dumb rats and smart rats. And the rats were identical. There was no difference between them. They just randomly selected them. And they gave them to some experimenters and said, put these through a maze and see how they do and test their times. And not surprisingly, the experimenters reported that the smart rats did much better than the dumb rats. And of course, there was no difference in the rats beforehand. But what was happening is the experimenters expected a certain outcome. And so whenever a dumb rat did well, they were like, oh, that must just be a fluke. Let's not count that case. Something must have gone wrong that time. Whenever the smart rats did well, they believed, oh, that must be real because it's a smart rat. So that experimenter's bias can really cloud our ability to be objective. And so if you walk around the universe believing life is everywhere, as a scientist, believing intelligent life is everywhere.
But how we can say that a life maybe it's everywhere in the universe, having no definition of life? We have no idea how matter...
I agree. But some people do.
On Earth, there is no definition. We have no idea how matter is transformed into life. There is no life in the quantum mechanism.
There's no theory of life.
There is no theory of life.
No, we don't know how that happened at all. And so that's what bothers me because the typical argument...
How we can define that dead rock include life, from Mars or another planets?
Yeah. How do we detect it?
Yeah. How we can detect it? Having no definition, having no scales, having no tools to define how to look at a life.
Yeah, so I think you're getting kind of like a definition aspect. Like we don't even know how to define life either. So there's the question of how did life start, but I think really we're talking about life on the Earth in that case. And then there's the question of how do you define life more broadly?
Yeah.
Is a virus alive? Is an AI alive? Could there be non-carbon life forms on other planets?
But I know scientists that think that virus, it's not life.
Yeah, I mean, that we don't have a definition. That's why people don't agree. So some people go for like an information theory-based perspective. Some people look at more Darwinian evolution arguments. So there's all sorts of different definitions. Probably the best definition is it's like porn. Like you know it when you see it. That's kind of honestly probably the best definition we have at this point. It is. I think all we can really do at this point is look for something which looks like us. And that's limiting because there could be life which is very, very different from us, but we're not going to recognize it. Maybe the entire galaxy is alive. Maybe the Milky Way is a living creature, for all we know. But we have no way to recognize that. We don't, because we have nothing to compare to. We don't know what on earth that would look like. We can imagine it, but that's just speculation. But we do know what life on Earth does. We do know the processes it metabolizes, it reproduces, and it has some kind of information continuation. So those are the things we could look for in another creature, in another organism.
Have you ever seen any mysteries, objects that could be alien technologies?
No, I mean, yeah, that a lot of astronomers look up at the sky a lot of time. I actually don't spend a huge amount of time at the telescope. I tend to use space telescope images rather than ground-based telescopes. But it is curious that the rate at which astronomers report seeing UFOs and UAPs and things like this is far, far less than the general public, despite the fact they are trained professionals who spend most of their time looking at the sky, in a professional setting at least. So that's, I always think that's kind of a red flag that maybe there's something going on there, that the more trained you are, the less likely you are to see one of these things.
What was the biggest red flag?
Well, I just think in terms of UFOs, if there really was a swarm of objects that were consistently and visibly, in visible light, these things are being reported, right? Being seen in our atmosphere and above the atmosphere, then you would think these surveys like the Zwicky Transient Factory or the Vera Rubin telescope, these surveys which are taking images of the sky every night, not just one, but thousands and thousands of images of the sky, broad, wide field. They're making a movie of the sky, basically. And they don't, it's kind of weird, they don't see any of these things in those same images. So either you have to be a conspiracy theorist or think that maybe there's something suspicious. But I mean, UFOs and UAPs, they're consistently in that low information zone, right? I mean, you look at the best photo from the 1950s of a UFO, and it's grainy, it's blurry. And you look at the best photo of a UFO today, maybe it'd be those Pentagon UAP videos that were released, it's blurry, it's grainy. So it's kind of startling that the quality, despite, I mean, you look at the improvement in camera technology from 1950 to 2025, it's just enormous. There's been huge commercial pressure to make cameras just so beautiful and sophisticated now and have, you know, thousands and thousands of megapixels and all this kind of stuff. And so it's kind of wild that the quality of our images, and everyone has a phone, everyone has cameras, and yet still
there's no proof.
And still the quality hasn't improved. It's always there. I think there's actually more claims now. There's a higher volume of claims than there were before, because everyone does have a phone, so that leads to a higher volume. But the quality is always in that low information zone. It's always a grainy image. It's never something like a super high resolution, beautiful 4K video of a spaceship that was landing on the backyard or something. So that's what bothers me a little bit about those claims. But I am very open-minded about it, and I do think we should study it. I do think we should, you know, there are some cases that are difficult to argue against, where, you know, there's Navy pilots which are reporting stuff, very credible witnesses reporting stuff. So it appears that there's something in the air. I don't know if I would believe it's aliens, but I would want to know what it is. I just think from a national security perspective, you'd want to know what it is that's flying in your airspace. So I think it's a problem that we should study. I'm skeptical that is the solution to the alien hypothesis. If I was an anthropologist trying to study an alien species, I would not want them to see me at all. I don't want to be interfering with that civilization by flying around in my magical spaceship that's going to disturb them and freak them out, because now you're interfering with the experiment. You want to observe them in their natural state, right? You don't want to be prodding them and poking them in weird ways. So I don't think it makes a lot of sense from a scientific perspective that they would be intermittently visible, like when they wanted to be. Like either they'll just be completely lurking from us and we won't know about them, or they would just come and say hello. I don't see this in between ground so much.
What do you think about Mars colonization? Why we need to colonize Mars?
I think some people feel that way. Not everyone, but some people feel that way because
what is the rational reason Why we should do this? Spending incredible amounts for that, monies for that.
Yeah, I mean, I guess you could make the same argument. Why leave Africa? Like, why? It will cost a lot of resources for
The desert
humanity
somewhere.
to, 400,000 years ago, all human beings lived in Africa. So why not just stay there? I mean, that's we evolved there, we developed there. Our bodies are meant to live in Africa, so why would we possibly leave and take the risk of living in a more hostile environment? So obviously the benefits of that are clear in hindsight, and it's not obvious what the benefits would be at the time. So I think human beings have clearly a natural tendency to explore the next frontier. I mean, it's just what we've done throughout our entire history is to look for new opportunities. And similar for, when people first arrived in America, they were, traveling, Lewis C. Clark, and traveling to the West to explore the new frontiers of America. I always find that time very exciting in history when there's still unknowns out there. And Mars represents an unknown. It represents possibility, and it also represents maybe a lifeboat. I think that's one of the reasons people often like to talk about Mars colonization. Something could go wrong on the Earth. Maybe a giant asteroid hits us, maybe we destroy ourselves in some kind of nuclear holocaust, but there would be a second seed of life, a second seed of civilization on Mars, potentially, if this plan worked out. The real challenge is, how could you possibly get Mars to a sustainable position where any colony we can imagine on Mars in the near future would be very dependent on the Earth for various supplies and materials and food. To get it to that fully self-sustaining position is probably going to take hundreds of years to get to. But it's hard work, but maybe we should start now to provide that lifeboat. And there may, by colonizing Mars, it would have boots on the ground, so it would make it easier for us to answer questions about Mars scientifically. It's very hard to do geology on Mars with a rover. It's much better to have human beings walking around on the surface who can dig and look at stuff and turn rocks over. So I think there's also a practical scientific benefit to having maybe not a colony, but certainly a long-lived habitat on Mars where people can conduct experiments.
Why we are so focused on looking for aliens and other civilizations?
We've always wondered that, haven't we? I think it's been a problem and a question that humanity has been thinking about since the dawn of civilization. The earliest thinkers were thinking about this. Metridius of Chios once said that, to think that the Earth is the only planet inhabited in the universe is to think that, in a field of millet, only one grain will grow. So in ancient thinking even, there was this plurality view that life should be everywhere in the universe. And I think the reason why, this is just my own personal hunch, I'm not a psychologist or anything, or a sociologist, but I think we are a social species. We evolved to be a social species. That's how we ended up taking over the planet, was by collaborating with one another to take down large game and build cities and eventually take over the entire planet. And so we like interacting with one another. And if you put a human being in isolation, it can actually be one of the most torturous things you can do. I think actually by the Geneva Conventions of War, it's forbidden to put somebody in isolation for prolonged periods of time, because it's so arduous to the human condition to be left alone. And yet, as a species, we are alone. And so I think we are going through a kind of psychosis. And even actually, if you put someone in isolation, they'll start to hallucinate companions. If you've seen the film, one of my favorite adaptations of that is Castaway with Tom Hanks, and he has Wilson.
I saw it.
Yeah, he gets obsessed with Wilson as a companion. And I think we are at risk of that when we look for aliens. We're so desperate to see something out there. We often see mirages and hallucinate what we think are other creatures in the skies, or in our data even sometimes, because we have this intrinsic need for others. And whether it, some people look for a parental figure, like a replacement for God. So it might be, instead of, maybe you leave your religion behind, and a replacement for that, a substitute to some people, starts to become some alien deity who will essentially come down and teach humanity the error of their ways and enlighten us with the Galactic Encyclopedia and all this technology. And in a sense, it is kind of a replacement for that theologic perspective of just sort of someone who can guide our hand and help us to mature. And perhaps one of the most terrifying things about us as a species is not only we're alone, but we lack any guidance. If you have a child and you just let it grow up in a room by itself with no input whatsoever, no one teaches it language, no one teaches it how to make do in the world, how to read a book or even to speak properly, all of these things, they'll be like a wild animal. And yet, as a species, we are completely untaught. We are self-taught all the way through. And so I do kind of think that we are desperate for that connection for someone else out there to help us through. And the greatest challenge for us as a species is that we might not ever get that, and we're probably going to have to figure this out on our own.
Could aliens be watching us right now?
Certainly, yeah. I mean, we have to be open-minded to that possibility. We cannot falsify that there is not a telescope which is around Alpha Centauri, which is observing us, or even much closer. There is an idea by the Benford brothers, a pair of science fiction writers, but also scientists, and they have this lurkers idea. So the idea with a lurker is some spaceship that's hidden, perhaps in the Trojan belt around Jupiter or something, or maybe in the asteroid belt. And it just is, to us, is inconspicuous. We don't notice that it is truly a vessel, and yet it has a large telescope on it, and it's just watching what we do. And to me, as science fiction as that sounds, I try to remain very grounded.
No, that's more science or more fiction?
I mean, the science would be, can you test it? So if it's not falsifiable, Karl Popper would say, it's not science. And so if your lurker is truly undetectable to us, there's no experiment we can do, even in principle. No matter how advanced we get, they'll always be one step ahead of us in technology, so we'll never be able to detect them. If they truly represent an invisible force, then it's not science, I would say. It's not amenable to the tools of science. However, the motivation, I think, comes from a grounded and reasonable place, and that's that the Earth is going through a rapid transition. For 3.5 billion years, we just had single-celled life on this planet. That was it. Only in the last 600 million years, we've had multicellular life. Only in the last million years, we've had hominids. And only in the last few hundred years have we had industrialization and technology developing on this planet very rapidly. So I think if an alien species was looking out to the cosmos, I think Earth-like planets are probably not that common. So they'd probably notice that Earth is unusual. They'd probably notice that life upon it is maybe unusual. And they'd maybe even notice that there's a civilization here going through a very difficult period, and it's going through its growth pains to try and mature into something more stable. And if you're an anthropologist, that would be the perfect study case to look at.
That's what I'd like to ask you. Don't you think that such controversial theses expose physics to the charge of being unfalsifiable?
So, some aspects of alien hunting are, I agree. I mean, to some degree, the alien hypothesis can never be disproven. So just take Mars, for instance, something close to home. We might run our rovers across the surface of Mars and look for life. And there has actually been recently some interesting evidence of life, but not a proven slam dunk of life. But let's say we just keep doing this and we just don't ever find that true slam dunk detection. And so it seems that maybe the consensus grows that there's no evidence for life on Mars. But that never proves that life was lifeless. You can't prove that, because there could always be another rock that you hadn't looked under, or maybe there was if you dig down 10 meters below this point on the surface, you'd find a microbe. So in that sense, we can never prove Mars is devoid of life, no matter what we do. Indeed, that's true for every planet and everything in the universe. We can never disprove life. So in that sense, life has this quality, which especially intelligent life as well, this quality which I call unbounded evasion capacity. UEC. I wrote a paper where we talked about these unique qualities, and that's unusual. There's not many scientific hypotheses which you can make that claim for, that no matter what you do, there's always a way it can dodge the bullet and evade your experiment. And it also has the ability to explain everything, which is perhaps even more problematic. There's nothing that can happen in the universe that you can't invoke aliens to say that's why that happened. If a star goes supernova, you could say, oh, an alien civilization was messing around with it and made that happen. If you detect an unusual fast radio burst, this high energy radiation from the other side of the universe, you could say, oh, that's a distant alien communication that just happens to stray into our line of sight. Even these interstellar asteroids that are coming through the solar system, we've had a lot of news and buzz about that being potential alien spacecraft. And that's kind of the problem with the alien hypothesis. It can explain everything. It is God of the gaps. It just fits into all of our things that we don't yet understand.
You mean also 3A Atlas, right?
Yes, 3I Atlas. I mean, and Oumuamua before that, where there has been some controversy that those objects, have some unusual aspects to them, which is true, but unusual compared to what? So they're unusual compared to the objects in the solar system, that's for sure. But not grievously so, I'd say. I mean, they may be the kind of the gases they produce and the movement of these objects seems a little bit anomalous, their trajectories and things like this. But at the end of the day, we don't have a basis of comparison because there's only been 3 of these things ever. So that's truly the sample to compare to. How unusual are these interstellar objects amongst the population of interstellar objects? If you're comparing them only to the solar system objects, well, it's perfectly reasonable they'd be different to the solar system. Why should every rock in the universe look like the rocks we have in our own asteroid belt? Surely there'll be different formation conditions in every single solar system, different metallicities, atomic compounds. So why should we expect everything to look the same? And certainly the sun is unusual. The sun is not a typical star even. So why should we expect the other material out there to look the same as us?
Do we know more what 3A Atlas is?
It looks very much like a comet. We're still studying it. It's still, as we speak, it's still on the way in. It's coming close to passing by Mars. It'll pass Mars in October, and then it will swing in.
But there is no tail.
There is a tail, yeah. So
There is?
There is a tail, yeah. So there was early Hubble images which caught the tail, but the tail was much smaller than the coma. So a comet has 2 main constituents. It has, obviously there's the nucleus on the inside, and then it has this coma, which is the dust and ice which is evaporating off and is in surrounding the nucleus. And then usually behind that you get the tail. Now this object is still very far out. It's still about 2.5 astronomical units away from the sun. So it's a little bit unusual for a tail. That's sort of the transitional period where a tail starts to manifest. So the fact it doesn't have a tail is not necessarily that weird, even at that point. But if you look at the Hubble images that were captured by David Jewitt, they were able to see evidence for a tail. It's a small tail. It's much smaller than the coma itself, but you can see definitive statistical evidence for the tail. And then a few months later, maybe 2 months later, Gemini South observed it, and it caught a beautiful tail, just a huge tail, which is exactly what the conventional picture you might imagine for a comet looked just like a normal tail. So at this point now we see clear evidence for both the tail and the coma. So it looks very comet-like. I think the current anomalies are just the constituents of it. Like it seems to have a lot of nickel, I believe. So some of the gases it's producing are maybe anomalous compared to what we expect in the solar system. But again, we don't have a sample to compare to. So maybe it just comes from a very nickel-rich solar system for all we know. There's no reason why that there's anything to forbid that.
So 3A Atlas, it's not alien ship.
Well, again, we can't disprove that. Yeah, I mean, that's the problem with the alien hypothesis. I can't ever say to you 100% confidence it is not alien. And no one can. And I can't say that about the moon. I can't say that about Pluto. There's nothing you can ever say with 100% confidence this is not an alien artifact of some kind, right? Because the aliens have too much infinite vastness of malleability, of flexibility to explain things, as we alluded to earlier. So I don't think we can do that, but I think all we can really do in science is to ask what does the evidence lead us to, and is there a plausible natural explanation? And if there is a plausible natural explanation, then in my book, I don't think we should be reaching for the alien hypothesis.
In your future book, right?
Well, I really mean in my account of logical thinking. But yes, I plan to write a book speaking about some of these aspects as well. Yeah.
David, if you could find answer for just only one question about the reality around, what it would be?
I have 2. I'm torn between 2. I think I really want to know how the human story ends. That's like a passion for me.
Regarding to AI development?
Not even beyond. Just, yeah, what happens to humanity? The times, I mean, an astronomer thinks in cosmological timescales, geological timescales, millions, billions of years. We tend to, as humans, think on much shorter timescales, decades, centuries. And I'm curious, if you go forward a million years.
Maybe we'll back to another Big Bang.
In terms of cosmologically, there's a very small chance of a universe collapsing, but I'm just interested in the human story of what happens to us. Do we spread to the other stars? Do we spread to Mars? Do we have a colony on Mars? Do we destroy ourselves? Do we turn to something else? Yeah, what is their interaction with AI? Do we get through these teething problems that we're having as a civilization right now, and do we develop into something more, or do we just turn to dust and that's the end of the human story?
And the second question is?
And the second question would be, how does this play out on other planets? So yeah, are we the only ones? Or I really would love to have that zoom out perspective of the full story of not just our civilization, but all the civilizations, to have that context of how does this unique experiment of an intelligent civilization, how does that play out?
I thought that you will ask about the human consciousness.
That is intriguing to me, but
human consciousness is.
Yeah, it's
how
not,
matter is transformed into consciousness.
I know there are physicists like Roger Penrose who think about that topic very deeply and are fascinated by it. And I have to say, I'm intrigued by it, but it's not the question that I lose sleep about. Yeah, I'm okay with the idea of consciousness as some kind of emergent property of these smaller components.
How do you look at AI development today? I remember my interview with Geoffrey Hinton. He said that we will be second, not the first, intelligent on Earth. You know, you are looking for aliens and other civilizations and intelligence somewhere there inside the universe, maybe here on the Earth. We are creating alien.
Yeah, we're kind of in a storm of so much excitement and speculation about what's going to happen with AI, for good reason, because it is clearly rapidly developing. I try to remain grounded about this topic. It is possible it will transform everything and be a true, an AGI, something comparable to human intelligence. I'm a little bit skeptical that the current implementation, these large language models, can do that, because there are aspects about our reality, if you think about how a ball falls to the ground, how we learn about physics, or the planets orbiting, that's not a problem of language. That's a problem of physical objects in space. That
you mean dimensions?
Yeah, even
dimensionality of the reality.
Yeah, the very basis function, which is essentially trying to use, which is language, to understand the universe, is not, I would claim, the same basis function that we use as intelligent creatures. Language is a manifestation of our intelligence, but it's not the lowest level of how we operate. I think even
because of human senses.
Not just because of senses, but I think we have an imagination. We have a capability to imagine. You can close your eyes and you can see a ball falling to the ground. There's no language involved in that. You can just see it, and you can imagine how it will roll down the stairs. And it's not obvious that these large language models, to me, will have the capability to do that kind of abstract thought that we are capable of. It's kind of difficult to put into language, actually, but I think that abstract is going to be challenging. And it's also not how our brains work. I mean, these large language models require so much training data to make progress, and it is impressive what they can do with that once they've got that training data. But a child can understand patterns with a few examples. It doesn't need, a billion examples of something to be able to. And you can show it 6 pictures of a dog, and it understands what a dog is from then on. It doesn't need a billion pictures of a dog to be able to do that. So there's definitely a lack of efficacy in the way these LLMs work that our brains do not struggle with. So it's doing something different to how we work. And so therefore, for those reasons, it may be that it's capable of AGI, but it's certainly not obvious to me that it's a guarantee. I think we could just keep hitting on these LLMs indefinitely, and it might never reach our level of intelligence. And I think that maybe is something we'll see in our lifetimes, whether it comes to bear or not.
Hello, quantum enthusiasts. Our partner, IQM, has created a free resource for you to learn and access real quantum computers. Create an account on IQM Resonance and start learning. Find the link in the description.
David, once you said that science is done by human being, what is, from your perspective, the most important human side of the science?
I think the most important side is to acknowledge our humanity and not pretend we're robots. I think sometimes there's a danger that scientists act as if we know everything, and especially when you exchange fields, sometimes there will be a physicist who's a brilliant physicist who thinks because I'm a brilliant physicist, therefore my opinion about some medical problem is as informed as anybody else's, or even better because of my background as this smart physicist. So I think sometimes scientists can overreach. Right? We have these trained expertise. I'm an astronomer. Astrophysics, astronomy, I'm happy to talk about. But if someone asked me to talk about I don't know, like the COVID vaccine or something like that, it's not something I feel comfortable talking about because I'm not trained in that area. I don't know anything about vaccines any more than anyone else. If you want to talk about vaccines, you should invite a vaccine expert onto your podcast or onto your newspaper, whatever story you're writing. And I think there is a danger of scientists sometimes feeling their ego gets a little bit too ahead of themselves, and they feel comfortable giving advice and wisdom on things which they really don't know a lot about. And so that can happen. And I think, our greatest danger as scientists is ourselves, is just ego getting ahead of us and not recognizing the humility of our own limitations.
I have some of your tweets. I think that they say a lot about you. To show what was before each thoughts. Yeah. And this is the first one.
Yes. Yeah, that was about I think when there was the issues with like Harvard funding, and Columbia was under attack for federal funding. So there's been a lot of pushback from the federal government in the US to try and restrict funds to universities. And there was scientists, I think, rightfully were explaining what the consequences of this would be to scientific progress in the United States. And there was a voice on social media that was saying scientists should not talk about this at all. But to me, that didn't make any sense, because scientists are the ones doing the science, and if they don't have the access, essentially the resources to do the science, it is obviously going to have knock-on consequences to society and to scientific progress. So sometimes, people would say scientists shouldn't be able to comment on anything except for specifically their field of expertise. But there's also the way that science happens, which I think scientists are experts also in how science actually takes place.
This is very, very interesting. Space is directional, but time is not.
Yeah. Yeah, I always think this is a curious feature of the universe, that we can walk forwards, backwards, we can jump up and down, left and right, but we can't go backwards in time. And it feels like a real tragedy that that's the case. And I so often wish I could hop forward, especially forward in time for me, to see how the story ends for humanity. But we're all limited in our capacity to do that. So if I had a wish, that would be one thing I would change.
And the last one, it's, that also with the Carl Sagan quotes, that one.
Oh, yeah. Yeah, this was the quote from his book, and it was also at the end of the film Contact with Jodie Foster, and I think a little child.
I remember I've interviewed Kip Thorne physicist, Nobel Prize winner. He cooperated with Carl Sagan also with contact.
Yeah.
Contact.
I so admire Carl Sagan, but I do think, like all scientists, there's no one is infallible, and we should be skeptical and challenge even our heroes. And I think Carl Sagan, I'd put in that bracket. So when he says this, he says it's a waste of space.
Are you a little bit philosopher?
I think a little bit, maybe, yeah. I think science and philosophy do overlap in many of these questions, yeah.
How do you define yourself today?
I don't.
Who are you, David?
Yeah, I don't know. I don't try to define myself too hard. I know what I am passionate about, and I guess that kind of guides my who you see in front of you, and that is understanding how the universe works, answering questions about our place in the universe.
You are more scientist, more communicators, more writer.
They're all different faces of the same beast. Yeah, I think when you do communication, it makes you a better scientist. And when you do science, it makes you a better communicator. And you get great ideas. So often when I talk about my research on YouTube, I will get people comment and say, what about this? Or have you thought about doing a video on this topic? And then I'll try to research a video.
So they are inspiring you.
Yeah, for sure. And they'll push me into areas that, the Halo drive would not have happened was it not for YouTube. I'm 100% confident of that. There's no way I would have written that paper. It was a product of me. If I was just a typical astronomer, I would just focus on exoplanets. That's my lane, just keep focusing on exoplanets. But then I was making videos about space travel and people really liked those videos. So it forced me to think harder about space travel. And the more I thought about it, the more I realized I could use my research ability to maybe add something useful to that conversation. And so if I wasn't doing that, there's no way I would have felt comfortable diving into that world. But I was quite well read on space travel by that point because of making all those YouTube videos about space travel. It had forced me to become essentially an expert in this topic that I had no formal training in. Like at university, there's no classes on interstellar propulsion systems, right? So this was something I essentially taught myself as a result of being a science communicator.
Your interviews are extremely popular on YouTube. I remember your interview with Lex.
Oh yes.
That generated for 12 million people around the world to watch that interview. How do you feel that everything around you?
It is weird to think of the numbers of people that watch something I've made. I think I would always freeze up. Like when we're having this conversation, me and you, I'm imagining this is just me and you. And if I imagine there's someone else watching this, I think I would almost second guess myself too much. And you kind of, the larger the audience is in your head, the more conservative and frozen you can become in your conduct as a communicator. So I think the most liberating thing is when you just imagine there's only one or two people, like a small audience, and then it feels much more like a natural engagement of conversation. So that's what I try to imagine, but of course I know it is having impact and people watch it, and so it is always very unsettling to me when someone says, oh, I saw your Lex Fridman interview, or I saw you on Joe Rogan, or whatever it was, and that's always weird, but it's nice. I'm fortunately at the level where I'm not a household name or face like Neil deGrasse Tyson is or Brian Cox is. I'm sure they would have trouble walking down the street. I mean, I know that because I've been out to lunch with Neil, and Neil always has to sit in a back corner of the room to make sure, because otherwise he'll just get harassed by people. And fortunately, I do not have that problem. I can eat at any restaurant and no one is going to bother me.
You are in a good place to be second Brian Cox.
No, I don't. Yeah, that's my aspiration, to be second Brian Cox. But I'm quite happy to be around the sides. Yeah, my aspiration is not to be the greatest science communicator of all time. I'm not doing it for that reason. This is not an ambition to take over the media world. This is just, I like doing it. It's fun. And my wife won't listen to me talk about space, so I need someone else to...
So why did you call your lab the Cool World Lab?
That's kind of a fun story, yeah. So when I applied to Columbia, I actually applied to another university, San Diego, University of San Diego before Columbia, and they have a group called the Cool Stars Lab. Cool Stars Lab, because they study the M dwarfs, these red dwarf stars in the universe. I thought it was such a great name. And as is a Cool Stars conference as well that happens. So I said, look, they've got the Stars group, and this was my pitch to San Diego. I said, you've got the Stars group, the Cool Stars group, I'm going to create the Cool Worlds Lab, and we'll be like a synergy, the two of us. One of us has got the planets, one of us has got the stars. Of course, they didn't accept my applications, but I thought it was a great branding, and so I used it in the rest of my applications, and Columbia liked it. So that's the naming. And I mean, the scientific reason is because we're interested in planets which are not hot. We don't want. There's a lot of planets which are very, very close to their star, and they're boiling hot, inhospitable to life. I'm interested in planets which are further away from their star, where life is possible. So hence, cool worlds.
What are you working on now?
The last thing two things. I'm working on finishing off our James Webb analysis of an exomoon hunt. So we have some fantastic data of a planet which we think is the most ideal planet for having exomoons we've ever seen. And we have this gorgeous data set from James Webb that we're about to publish. So we're just making the final tweaks to that. So no spoilers. I'll try and keep my mouth tight about that until the paper comes out. And then the other one, I just published a paper on thinking about more of a statistical paper about this "are we alone" type stuff. And it was asking, why do we live around a sun-like star rather than a red dwarf star, which is what I alluded to earlier. And I think the most obvious answer to that, which I propose in this paper, is that there's something wrong with M dwarfs fundamentally. And my claim is that probably about 2/3 of all stars in the universe cannot have intelligent creatures on them. And these are the low mass stars. So I think the low mass stars are prohibited from having intelligent life in them. So it's a bold claim, but I think it's well backed up in this paper with some arguments and some hard statistics.
I remember I read an article about a woman. She saw your interview somewhere, doesn't matter where, and posted, she drew a sketch and posted on Twitter. And to her surprise, you replay, I think, in less an hour. Do you feel how deeply your work touched the people?
Yes, I think it's always hard to judge exactly how much impact you're having, but the topic that I'm researching, which is looking for planets and life in the universe, is a topic which I think everybody has an intrinsic interest in, or at least most people. I'm always blessed that when I step into a taxi and they ask you, oh, what do you do for a living? And you say, well, I look for planets in the universe. They will instantly strike up a conversation with you and it will connect. So I think it's a universal topic in that sense. And I mean, as a communicator, I don't know exactly why people have been gravitating towards the content I've been making. I just try to convey my own personal passion, and my philosophy as a communicator is it's a bit like being in love. I just love this topic so much. When you're in love, you want to tell the world about it, and that's how I feel about my work.